Very good morning, students. So welcome to IIT NEET Foundation, our Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participants of class 8th for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 8. Our ongoing chapter, motion in straight line. Today we are entering into the session number 2. So far we completed one session on this particular chapter, chapter number 2. So today we are going to have second session. So before going to for today's session, once we recall what we learned in the last class. So as the topic is of motion, as I told you, the motion of a body may be either one direction, two direction, or three direction also, right? So here we are only discussing about the only one direction, that is straight line motion. So this all motion, everything discussed under the heading of mechanics. So mechanics is the branch of physics which deals with the motion of a body, right? So mechanics is knowing about the motion. Study about motion of a body comes under a very big branch of physics called mechanics. And again, this mechanics is classified into three categories. One is kinetics. Study about the body at rest. Second one is kinematics, what we are learning today. That is this topic. Kinematics, study about the motion without cause, no cause. We are not discussing about what is the cause of motion, right? But whereas third one is dynamics. So study about the motion along with the cause of motion, that is force, right? So like this, the total branch of mechanics deals about all the three. But here, as we are discussing only about the motion, it comes under the kinematics. We are not discussing any cause here. Without considering the cause, we are dealing only with the what is motion, on which you are learning in the lower class also 6th and 7th. What is motion? What is rest? How many types of motions are there? Right. All these things we learn. Along with that, what are the terms which come across during the motion? When a body is in motion, what happens? What case of physical quantities will come across? Okay, that's all we discuss in this chapter, right? So what we learned in the last session, we started the kinematics chapter, that is motion in one dimension or straight line, where we discussed about what is kinematics, what is the position of a body, that is at rest, and what is rest and motion. We discussed rest is nothing but a body remains same position for long time, or body does not change its position with time, is called body is at rest. Then body changes its position with time, it is called as a motion. Okay, that we discussed. Both are interrelated. Now when you come to today purpose, we are entering into the very important topic. So before going for this topic, let me show you one videos on motion and types of motions, just to recall what you learned in your lower classes, right? Just about motion and rest and
on the concept of rest and motion in physics. By the end of this video, students would be able to define terms like rest and motion. They would also be able to understand why motion is relative. I have given links related to this topic in the description box, so do check them out for more information. Now, if you look around, then you might find some things moving and some things not moving at all. Moving things around us includes cars, buses, trains, birds, animals, human beings, etc. All these things move from one place to another. Apart from these examples, things are in motion inside of our body too. For example, Blood moves through blood vessels. Our muscles move when we work or play. Heart pumping blood, and many more such examples can be found in nature. We do not see these motions, but we know about them from their effect because our life depends on heart pumping blood and we need muscles movement to perform various tasks. So we can say that motion occurs due to movement of a body. Now let's talk about some objects like a tree, house,
They cannot move. They
school,
are at rest.
electric,
Poles.
pole, etc. These objects are stationary
They are at
objects.
rest.
Now they remain fixed at their position. From these examples, we can say that few things around us are moving and few of them are stationary. Let us now define terms rest
What we learned in
and
the last class.
motion. A body is said to be at rest if its position does not change with the passage of time.
Right. That is a rest.
If the position
There
of
is
an
no change in the
object
position. The body is said to be at rest.
changes
Right.
with the passage of time, it is said to be in motion.
Motion. With changing the time to time, it changes the position. We can call it as body in motion. Okay.
One common feature of all moving bodies is that they change their position with time. The position of a body is known by its surroundings. So, for a book kept on a table inside a room, the table, walls, and ceiling of room make the surrounding. To be more precise, the state of motion or state of rest of a body should be defined with respect to its surroundings. As an example, look at the book lying on the table in a room.
For
When
clearing
nobody
your
is near
explanation,
it, then the
easy way.
position of the book with respect to tabletop, walls, or ceiling of the room is not changing. So, the book as seen from the room is at rest. We can say that book is at rest with respect to the room. Now you entered the room, pick the book, and begin to move out of the room with
Of the room.
the book. Now in this case, distance of the book from the walls changes as the time passes. So the book is in motion with respect to the room. Now let us look at the fact that both rest and motion are relative.
So this is the last what we discussed in the last class.
This statement means that any object which is in motion with respect to one person or object might be at rest with respect to another person or object.
Comparing.
For example, consider the case of book kept on the table. Now you picked up the book and started moving. Now this book in your hand when you are moving is at rest. But the same book is in motion or moving with respect to
Walls
of the room. To get more clarity on this statement, let us take a case of a person observing another person inside a hot air balloon. Now, for a person A who is observing
Very
another
simple
person
example to say
B
why they are
in
related.
hot air balloon from the ground, the person B is in motion with respect to him or ground. Now, this same person B is at rest with respect to the hot air balloon, or another person, say person C, sitting beside him in hot air balloon. This is because both of them are sitting inside the balloon and both are not moving with respect to each other as time passes. So both rest and motion are relative and depend on with respect to which object or body we are observing it. I hope you now understand the
Right. So this is a clearly understood that both are relative terms. Some more we'll see about the
motion and its types. Let's have a quick
types of
review.
motions, which you just recall.
Let's start with motion. In simple words, if a body is moving, it's described as motion. That's all. In slightly more technical words, motion is defined as a change in the position of a body with time. Yes, change in the position with time. For example, when an object is moving from point A to point B, it's changing its position with time. We saw that the time is also changing along with the position. So it is undergoing motion. What are the types of motion that we had studied previously?
Regularly, what will come?
We have seen 4 types of motion. The simplest of all is the rectilinear motion. It is the motion of a body in a straight line. The example that we saw earlier is of a rectilinear motion. Object is moving in a straight line from A to B. There is another type of motion called the circular motion. What can this type of motion be? It is the motion of a body along the circumference of a circle. Example: motion of the earth around the sun is an example of circular motion. The third type of motion that we saw is a rotational motion. It is the motion of a body around a fixed axis which is passing through the object. This is important. The axis has to pass through the object. Example of rotational motion is a ceiling fan rotating along its axle.
It's the point.
So you see that if I draw a hypothetical line called the axis of rotation, then it's passing through the fan. And the final type of motion is a periodic motion, which is the motion that repeats itself in equal intervals of time. Can you think of any example of this type of motion? Any object repeating its motion in equal intervals of time will be undergoing periodic motion. Assume an object is moving in circles and is covering each round every 3 seconds. Is it performing a periodic motion? Absolutely. Since it's repeating its motion along the same path every 3 seconds, it is undergoing periodic motion. But wait a moment. This object is moving along the circumference of a circle. So it is also undergoing circular motion. So what can you conclude from this example? We can say that an object can undergo more than one type of motion at the same time. Here are the few of the examples of motion in our everyday life. Go through them well and tell me what type of motion each one of them represents. And note that one example could also have more than one type of motion. The first one is clearly rectilinear motion. It's a car moving along a straight line. The second one is interesting. Most of us would have guessed rectilinear motion after seeing the word straight. Which type of motion are the wheels of an automobile performing? Are they undergoing rotational motion or rectilinear motion, or both? Since the automobile is moving in a straight line, its wheels are undergoing both rectilinear and rotational motion at the same time. What about the simple pendulum? We know that a simple pendulum performs to and fro motion. This to and fro motion repeats itself in equal intervals of time. So it's undergoing periodic motion. Now let me ask you a question. Suppose you want to travel to city B from city A. Which mode of transport will get you quicker to the destination? A bicycle or an aeroplane? Obviously, an aeroplane. Because the speed of an aeroplane in air is much quicker than the speed of a bicycle on a road. But what is speed? Keep watching our videos to know more.
Right. So, we learn about what is exactly the motion and various types of motions which you learn in the 6th and 7th classes. Just we recorded before going for our next topic. That is, our next topic is when a body is in motion, what kind of terms will come across? So terms related to motion. Imagine a body is moving. So every moving body calls some distance, right? Distance, definitely. And also displacement, even both are sound same, but there is a difference is there. Distance will come, displacement will come, right? Displacement. Sometimes speed, it moves some speed or velocity, or it changes the speed, that is acceleration or retardation. And of course, time is common whether body is moving or not moving. So whenever a body starts in motion, these all terms will come across. So these two sound same, these two sound same, these two sound same. They look same in our regular uses, but there is a difference in terms of physics. So that's why we are discussing about what is the difference between distance and displacement, speed and velocity, acceleration and retardation. It's also called as negative acceleration or deceleration, right? So we start with the term distance. So it is defined as length of actual path followed by a body. Length of actual path. Suppose we have here A to B, right? A body want to go from A to B. It moves like this and go to B. So this total path is called distance. The total path followed by a body. Actual path, right? Here path is following like this. So this is called a distance. Clear? But this path, the shortest path is called displacement. The total path, suppose if I ask you to show your nose, you will show like this. This is the distance. You can show like this also. That is displacement. Sorry, this is displacement, that is distance. So the shortest path or actual path followed by a, suppose this is your house, this is your school, right? 2 kilometers are there. So daily morning time, anyway you are in a hurry, you will go directly to school like this. 2 kilometers, which is the distance. But while coming home, in between here, your friend house is there. Right? Your friend's house is there here. So while coming to home, you go like this. Total it is a 3 kilometers. So this is the actual path you followed this is called distance. Morning your distance is only 2 kilometers, but evening it becomes 3 kilometers because you came from some other time. The entire path which you have traveled is called distance. Right? It is measured in meter, centimeter, kilometer. Higher units also there, miles, so many are there. And the dimensions already we discussed. Distance is nothing but length, L1, M0, T0. So distance traveled by a body never decreases with time. So there won't decrease, that is, it won't be negative. Distance is always positive. There won't be decrease in the distance. The distance traveled by a body can never be negative. It is a scalar quantity. Scalar means this is only magnitude, no direction. As there is no direction for the distance, it won't be negative. We cannot consider distance as negative, and it won't decrease with time. Okay. Next, displacement. Displacement is the shortest distance. Magnitude of displacement is shortest distance between the 2 points. So, for example, from Hyderabad to Vijayawada, we can go directly from Suryapet and Kodara. Or you can go through Khammam also. Or you can go through Adilabad also. So many ways are, so many different buses will go different routes. But what is the shortest distance? That is considered displacement. See, from A to B, we can go like this, we can go like this, or we can go any way. Like this also you can go. But what is the shortest? Shortest is AB. And the shortest distance is called displacement. Total path, the total length of the path is called distance. The shortest distance is called displacement. Remember. So, displacement is a vector quantity. It has both magnitude and direction. So, it can be negative. There is a possibility of getting negative also. Even zero also. Displacement can become zero. For example, see, A to B is there. A person moved from A to B. After reaching again, he came back to A. When he came back to A, what is the displacement? Because it is initial position only. Displacement is 0. Positive forward direction, negative. Suppose this 2 kilometers. He moved 2 kilometers forward. Again came back 2 kilometers. So 2 minus 2 becomes 0. He not moved anywhere. Even though he covered some distance in both direction, displacement is 0. So there is only one case where distance and displacements are same. So one case only, distance is always greater than displacement. Except one case, equal to, where straight line. Suppose a body moved from A to B. So distance is say 2 kilometers. So what is the distance? 2 kilometers only. What is the displacement? 2 kilometers only. Both are same. Only one case, in case of straight line, what we are discussing now. Remaining all cases, distance is always greater than displacement. Okay? You can see so many examples are given here. You can see the diagram. So, a body coming from here, a cyclist, right? He is coming from here and moving so many places. So, here he come like this and he moved here 200 meters. But what is actual path is this, 120 only. The shortest distance is 120. Actual path is 200 meters. Right? So distance is nothing but entire path where you travel. Displacement is the shortest path. So these are two terms which come across when a body is in motion. Distance and displacement. Clear? So as you move forward, see there are some more examples are given. Right? A professor places left and right while lecturing. Her position related to Earth is given by X. So what is the displacement and distance? The 2 meter displacement of professor related to Earth is represented by arrow pointing towards the right. So there is a displacement as direction as well as magnitude. So it is a vector quantity, whereas distance does not have any direction. It is a scalar, whereas displacement is vector. So distance is the entire path, the total path of the body followed by a body is called distance, which cannot be 0 or cannot be negative, or it won't changes with the time. It won't decrease with time, and is always more than the displacement and more than and equal to the displacement. Equal is only one case, that is when body is in a straight line. So displacement is nothing but shortest distance between initial position to final position. Shortest distance. It is a vector quantity because it has both direction and magnitude. Displacement can be 0 or can be negative also. Can be 0 or can be negative. Right? This is the two important terms come across when a body is in motion. The first two terms. Okay. Now, when you move again, another two terms are there. Both sound same, but difference is there. Speed and velocity. So speed is nothing but distance by time. What? Rate of distance. Distance by time is called speed. Whereas velocity is nothing but displacement by time. That's all. There is a difference. Displacement by time. So obvious, speed is a distance, but rate of distance you can call. So distance is scalar quantity. So definitely speed also is scalar quantity. Velocity, displacement by time, it is a vector quantity. There is no much difference. The time rate of change of position of an object is called speed. It is tells how fast object is moving. You are going speed. There is a speedometer is there on vehicle. Speedometer, which shows the how much speed you are going. Right. So dimension formula of speed. Speed is nothing but distance by time. Distance is L1. Time is T1. So when T1 goes up, L1, T minus 1. That's what. M0. So units are meter per second or centimeter per second. Okay. So there are different types of speeds also that you can see. Speed is not constant. So it changes. It may be uniform speed, non-uniform speed, average speed, instantaneous speeds. So many types of speeds are there. So that we'll discuss in the next class. Right? Speed followed by the velocity also. So once you see about the speed, automatically velocity also is same. Types of average speed, time speed. So instantaneous speed. Then comes velocity, same. Velocity also we have discussed. Then acceleration. what is the deceleration, right? Types of accelerations. Then we'll come across some equations, mathematical formulas. So we'll discuss in the next classes. Okay. So very interesting topic it is. There are 4 equations are there related to motion of an object. So those 4 formulas are the basic formulas in the physics. The formulas can be changed under the gravitational force. Okay. So a lot to discuss in the next class. So what we discussed today is about after knowing about motion and rest in the last class, today we have seen about some few types of motions, just to recall the earlier classes. Then we enter into the terms related to motion. When a body is in motion, the body will have distance, displacement, speed, velocity, acceleration, retardation. So we discuss about 2 important, that is speed and distance and displacement clearly. And we introduced about the speed also. So in next class, we'll discuss what are the types of speeds, and what is velocity, what are the various types of velocities, what is acceleration, types of accelerations in details, right? So hope you are clear about this. So go through the material and update your levels worksheets, complete the worksheets in your notebook and get ready for the next exam, right? So that's all for today. Thank you very much, all of you. Have a wonderful day. Thank you.